Right, we have a vector question here. I tend to find these the most difficult in AEA papers because they're just so different every time. And vectors is kind of only touched upon in A-level maths, to be honest, and suddenly you get a question like this, which is like just such a higher level. Right, let's give it a go. So we've got position points A and B with position vectors little a and little b, respectively relative to an origin. So maybe I'll just draw it like that. Then this is going to be O, this can be A, and this can be B. And they're such that OAB is a triangle. So I might just connect it like that. And I should also call that then A. And we've got the magnitude. I mean, this is standard notation. To find the magnitude of a vector, you just make it lowercase. And we've got B here. And then we have a point C with position vector C. So why don't I make it here? And it bisects the angle OAB. So that means if this is theta, then this is theta. Okay, getting a diagram is a good diagram is really important for this sort of question. Then, right, that's all the information we have. We're then asked to prove that the vector BA minus AB is perpendicular to C. So I can extend vector A to get BA. I'm going to assume that B is greater than 1, just it's not actually going to matter, but it's going to be easier to draw a diagram for. Okay, so this whole vector, I won't add it there actually, I'll put it here, is now going to be B times A. And similarly, I can multiply my vector B by A, so I've got A, B. And then the vector BA minus AB means I go along BA, but I'm going to go minus AB. It actually means I'm going to go from here to here. So I'm going to label this one, I don't know, this can be X and this can be Y. And we're being asked to prove, okay, let me just add that vector in as well. So BA minus AB is going to be going this way. Okay, we're trying to show that it's perpendicular. Right, well, here's the thing. Because I've got this vector AB, the magnitude of this is just going to be AB. And meanwhile, the magnitude of this one is also going to be AB, which means I have an isosceles triangle. And by definition, when you have an isosceles triangle, you split it down the middle, it will end up going to the midpoint, and this will necessarily be a right angle. So that is actually enough evidence. I don't think I'm expected to, write a lot, but I suppose I could say, right, I've got a shared side, I've got equal angles, and I've got an equal side here. So that means that these two triangles are congruent, and therefore this angle is the same as this angle, and these two angles will be the same, and because they're shared between 180, this must be 90. That would be one way of proving it. I think it's just accepted that we can say it, basically. So I just need to write a few words down. We have an isosceles triangle split into two equal parts. Actually, I know I've put C, like C looks like it's very close, but it's not necessarily on the line. So I might just move it a bit further away. And I'll call this M, I guess. Therefore, OMX, the angle, is equal to 90 degrees. Therefore, YX is perpendicular to OM. But BA minus AB lies along YX, and C lies along OM. Therefore, BA minus AB is perpendicular to C, and we're done. Okay, now I don't mean to sound like that is obvious to do all these steps. Um, even this first part is a bit of a challenge, I think, but hopefully with the explanation that I've given, you're happy with this first part. Okay, next up, we're given the point D with position vector little d lies on the line AB between A and B. I connected that before, so maybe I put it here. And that's going to give us a position vector like that. Okay, we need to explain why D can be expressed in this form for some scalar lambda with lambda, sorry, 0 less than lambda less than 1. Okay, well, we can work out AB to start with. And the AB is just going to be minus A plus B, or B minus A. So A to D is going to be some fraction of that. And that's where I'm going to introduce my scalar quantity. It's going to be lambda times B minus A. And I've got AD, so O to D, which is little d, is then going to be A plus my vector A to D. This actually come together quite quickly. Now, I've not quite got it in this form, so I'm going to need to expand the bracket. And then I can factorize out, or let me write it as this first, A minus lambda A plus lambda B And I've got a common term of A, which I'm going to put afterwards. So it's going to be 1 minus lambda times A plus lambda B. I probably should have just quantified earlier on that lambda is going to be between 0 and 1. And I've done this part. Nice. Hey, this just leaves us with the final part of the question. I'm going to, first of all, redraw the diagram here and substitute the question in. Okay, so I've got to remember what we've actually done so far, but we're now given that D is on the line OC as well. So in fact, I'm going to need to move it here and here. And we're asked to find an expression for lambda in terms of A and B only, and hence show that this ratio is true. Now, from before, remember, we have this. Still okay. But now we have an extra piece of information. It's also along the line OC. So D is going to be some constant times vector C. And to make life a little bit easier, C could be anywhere. So consider C is in the same place as capital M. So why not let it be on this base of the triangle? Okay, you can work more generally, but just cancel that constant out later on. Now we have xy here. So that means I've got xm or xc. Oh, sorry, it's going the opposite direction, isn't it? I've got yc, yc, because this is the midpoint, because remember we split an isosceles triangle into two, because it's 90 degrees, then yc is going to be a half ba minus ab. And therefore c is I'm going to go along ab and then add the yc. Let me expand the bracket while I'm at it. So that's going to become a half AB plus a half BA. And therefore D is going to be K times that, a half K AB plus a half K BA. Hence, we can take what we had up here and set it equal to this other value of D that we've got from the fact that it lies along C. Now, A and B are not parallel vectors. So it must be that this here coefficient is equal to this. Yeah, there's no way, this is essentially like this is not just an equation. This is whatever A and B are, this is true. So it must be that 1 minus lambda is equal to a half kb. And similarly, lambda is going to equal a half ka. Sorry, I shouldn't have a underscore. Yeah, that's just a scalar quantity. Um, Now what to do? Essentially I want to find lambda, but it might just be easiest to find k first. So I'm just going to substitute it in. 1 minus a half ka is going to equal a half kb. If I multiply through by 2, I'll get 2, and I'm going to add this onto both sides. 2 is going to equal ka plus kb, which is ka plus b. So k is going to equal 2 over a plus b. And lambda is then going to be a half a times 2 over a plus b. These are going to cancel, and we get a over a plus b. Right, we have one more part of this question to do, and that is to show that the ratio dA to dB is equal to OA to OB. Now, OA is the length is just A, and OB the length is just B. So the hard bit is going to be getting these magnitudes and simplifying the ratio to A to B. Having said that, we have some previous information about AD all the way back up here. There we go. We now know what lambda is, so we can substitute in for that. And therefore, the length dA is simply going to be the magnitude of this vector. So I can write it as lambda times the magnitude of b minus a. Okay, that's one sorted. Now we don't know what b minus a is, but hopefully we'll find it in the other term and then it will cancel out. So we're left to find dB or BD, but let's go with dB. dB is going to be dA plus AB. Which is actually then the same as AB minus AD. I've just made the vector go in the opposite direction, make it a minus, because I know what both of these are. B minus A, and I'm going to minus lambda B minus A. There's a common factor of B minus A, so I can actually factorize out 1 minus lambda and then B minus A. And therefore dB is just going to be the magnitude of this. Now, lambda is between 0 and 1, so this will be positive, and I can just write it. I don't need to, do anything with that, and I can just write it as 1 minus lambda, again, times the magnitude of b minus a. Brilliant. Hence, we're on to the last bit. dA to dB is going to equal lambda times b minus a to 1 minus lambda to b minus a. I'm going to divide through by b minus a, so it's gone. Lambda, remember, as we showed earlier, is actually a over a plus b. I'm going to put it over the right-hand side over a common denominator. It's going to be a plus b, then minus a, all over a plus b. These cancel, and from that I can just times through by a plus b. Therefore, I'm going to get a to b, which is equal to OA to OB as required. Okay, now I think that's pretty tough. I mean, I might have made it look like it was easy, I don't know, but it's this question has been a tough one. Um, just going to recap, it's like a bit like, I've never seen a question quite like this, first of all. I know we're using the sort of principles of vectors, but getting the geometrical picture correct to start with was pretty essential. Just one little point. If you have studied further maths or A level on the old syllabus, you could technically use a dot product for part A. I'm not sure it really helps later on. So I haven't spoken about that, and I'm not going to. We did this by constructing a diagram, carefully creating this isosceles triangle, and hence proving that these two were perpendicular. Here we took a different tactic. We put a point in, required some manipulation, but then we managed to get D as shown. Then when it's on the line, we move to D here. Again, it involves quite some, technical, I think, calculations in order to rearrange and work out what lambda was and K was. And remember, I did decide to put C onto this point here. I think if you do otherwise, you just have to times by a scalar. You can still get the answer. But I made I said like why it can be here, so let's just make it here. I just made the scalar quantity 1 essentially, I think. And then finally, another drawing of the diagram. Looking at the ratio, we've got OA to OB. That's quite simple. And we can use previous information, AB, to work out, we got AD as well to work out this length, and similarly work out DB, put them into the ratio, simplify it, and we managed to get that it is the same as OA, OB. Okay, well done.